Hello everyone, this is Adrian from the Things Industries, and today I'm going to talk a bit about our integration with Azure IoT Hub. A bit of an overview of what we're going to go over today, the architecture of the integration, where it runs, how it runs, what type of resources do you need, a bit of a demo on how it works in our test environment, and then a Q&A session. Throughout the presentation, I'm going to do everything live, so you're going to see actual end devices sending messages, gateways sending, receiving them, and probably failures as well. But the good news is that this is just more material for you to learn on how to debug issues that you may encounter during your usage of the Think stack. So the underlying idea for the Azure IoT Hub integration is that it allows you to connect all of your LoRaWAN devices to an Azure IoT Hub. The IoT Hub that is then your gateway to the rest of the uh, Azure facilities. So for example, let's say you want to get reports of your data, you can get them through Power BI into nicely viewed dashboards or automatically generate reports and so forth. The architecture of the integration is based around the number of resources that run within your account, your own Azure account, and which the Think stack actually uses. So how the flow normally works is that you deploy an Azure IoT Hub within your own customer account, as well as an event hub that is used for communication with the stack. And the stack automatically creates the end devices from that you have registered in the Think stack in the IoT Hub. Afterwards, your traffic is live both as telemetry and as device twin desired and reported state. We are going to go a bit more in details once we reach that point. The resources are fully serverless, so you pay only for what you use at the end of the day. And the idea is that the costs are minimized this way. We also try to be very mindful on how we use telemetry messages and so forth. Everything that I'm going to present today should be already present in the documentation. So I'm going to walk with you through the documentation on how to deploy it, how to actually use it, and so forth. And maybe the only thing that should be extra is a couple of tips and tricks. Let's go now to the deployment. The deployment guide has two prerequisites. You need to have an Azure account and an Azure resource group and an application in the Think stack. I'm going to be using a private test tenant that I have, but you can follow this guide either on the Things network or on your own private V3 network. The integration starts by creating an API key. This is the API key that the resources within your own Azure account use to basically submit information to the Think stack. So when you want to actually control your device, you need to send a downlink to the device, and this is how the IoT Hub gets access to your the Think stack instance. I have already over here a test application that I have, and I simply go over integrations, Azure IoT Hub, and I have everything that I need in order to do a deployment. I'm going to generate an API key, and afterwards, I just click on Deploy Template. This is just loading up. Afterwards, all that we need to do is to copy paste a couple of details that identify your own stack in the meantime. So there we are going to have to provide the application ID. This is pretty simple. The cluster address, this identifies to which the Think stack instance the integration will speak with, and the API key. So we start by selecting, let's say, the resource group. We can give it a name suffix. So we put a suffix to all of the resources that we have to deploy. In this case, I'm just going to use Adrian Webinar. And we start copy pasting the rest of the field. So first we need the stack cluster address. So we just copy it from the console and put it here. Same for application ID, exactly the same idea. And finally, the API key. This is all that you need in order to start. I'm going to just put a 2 here. Now Azure Resource Manager is checking if everything is all right. So if every name is available and so forth, and afterwards I just have to click create. I'm not going to go through this because deployment takes a couple of minutes and it's not really useful to wait just in the middle of this. Instead, I'm just going to show you the final screen. Once the deployment is over, you will be presented with this deployment screen, which says your deployment is complete. And all of the resources have now been created into your account. Now, what you need to provide to the thing stack is these two fields, Azure Iot Hub's hostname and Azure Iot Hub access key. Those are conveniently available as outputs. So you can just copy paste those from here. I already have them, and click Update Azure Integration, and you're good to go. After you've done that, you can actually see the IoT Hub. We will start by going into the IoT devices view. Here, because this is a hub which I've already created, it already contains my end devices. For the purpose of this demo, we are going to work with two end devices. The Things node, which is going to be basically acting as a sensor which sends telemetry. Let's actually just start it and see it joining the network. And also the Things Uno. The Things Uno we are going to use as an actuator. So it's a small device with a LED on it, and we want to control the LED via LoRaWAN. I'm going to also plug this one in. One moment. Okay, and now we wait for the device to join. The Things node has joined, and we already have the message coming through. This is basically the telemetry that you will receive from your own LoRaWAN devices. Let's close this. And the Things node has the ID that I gave it over here. I'm just going to remember that it ends in 3dBA. And I'm going to look at the screen that I have in Azure Iot Hub. Azure Iot Hub has this beautiful capability called Device Twin, in which basically you can see the last reported state of your end device, see some tags for the end device, so add some metadata, and actually control your device via desired state. So over here, let's walk a bit through this. So you have device ID, which corresponds to the device ID that is set in the Things stack. You also have tags. So this device was created, I created it via Azure Iot Hub, and I have all of the LoRaWAN information over here. Device UI, join UI, LoRaWAN version, frequency plan, and even version identifiers. These are used for our LoRaWAN device repository. So automatically, if you want to create a device via Azure, you can also specify what kind of device this is. In our case, is the Things node, and we automatically provision the payload formatters for you. We can also check the properties that have been reported by the end device, and we have two types of properties, desired and reported. For sensors, the desired state is not as important as the reported state. This is basically the last reported state of the end device. So we can check the date at which the device has joined the network, so it has successfully joined. And we can also look at the last sent decoded payload. So right now, let's refresh it. This is, for example, battery 4000 milliwatts. The event has been interval. The device sends some messages at a specific interval, light in lumens and temperature. And this corresponds to the type of data that we have the device send every minute or so here. On the other hand, we have the actuator, in my case, the Things Uno, which we can actually control. So right now, the Things Uno it has a LED, it's reporting it as being active, and I also see it physically, but unfortunately the camera cannot see it as well, so I'll just show the state that you see over here. So the LED is on. And let's say I'm interested in actually controlling this device. Usually, if you just work with plain the Things stack, you would schedule a downlink that controls the device. When you use Azure Iot Hub, you can actually submit this type of desired change, something that you want to change for the device as part of the desired properties. So properties desired, decoded payload, and then the name of the field. Once we press save, we are actually generating a downlink automatically. So the change fields are used as decoded payload, and we send a downlink to the end device. Now, since this downlink was scheduled not within the RX1 of the last message, so not within the 5 seconds of the first message, it's going to be sent only now. And I already see that the LED has gone on, and from the next message forward, we have the LED as being on. We can also check this in the device twin decoded payload. So I'm going to refresh, And now the last reported state of the actuator is actually that the LED has been turned on. Pretty basic, but it gives you a bit of a feeling on how this should work. You change the desired properties in order to modify the end device, and then as the device receives the message, you are going to see the changes in the reported state. Keep in mind that LoRaWAN is a protocol in which you have basically two types of communication when it comes to downlink, confirmed and unconfirmed. By default, any change that you are going to send by updating the desired state is going to generate an unconfirmed downlink. What this means is that sometimes this downlink can be lost over the air, and your best bet is to watch on how the device reacts to it. So you try to schedule a desired change, you then watch, so you look at updates to the reported properties, and in case the state doesn't change, you send again a new message. The reasoning on why this kind of logic needs to be built by you is in order to save battery power. So we allow you control over whether or not you want to try to schedule a new downlink immediately, or you want to block, or you want to try another command, and so forth. This shows a bit of the capabilities that we have with desired and reported properties. And the nice part about using Azure IoT Hub is that you can actually you can create devices directly from here. So my things node, let's say I want to enroll it completely via Azure IoT Hub. The nice part is that I can just, I can create it directly from here. So I'm going to delete it. This is intentional. And once I delete it, I have to select the right one. Yes. Now the device has been deleted. Nice. And I'm also not going to see here anymore in the list. So let's say I don't want to touch anymore of the ThinkStack console, and just in order to ensure that I have only one pane of glass and I do everything to IoT Hub. I click on Add Device. I'm just going to call this the Things node. I'm going to save it, and right now the device is created in the IoT Hub, but not in the Things stack, because we don't have the information that we need, basically the LoRaWAN standard information. So the version of the end device, device UI, app key, and so forth. How you can provide those with in order to enroll your actual device is via tags. So the device twin that you see over here is basically unchanged. This is the default device twin that you get after creating an end device. And now we have to provide tags. Tags are some properties which are meant to be static and are simply metadata of the end device. So I'm going to provide all of the information as tags. So LoRaWAN, it's a whole JSON object, and it contains this information. So device UI, join UI, LoRaWAN version, frequency plan, and so forth. And once I click save, automatically what should happen is that the device should be created uh, in the thing stack. This may take a bit, since basically we are not using any reserved compute resources. What happens is that you may feel a bit of a delay when issuing commands. If you want to actually speed this process up while deploying the template, you may specify a custom plan for the Azure function that is used to send data to the thing stack. I'm going to show this in a minute while we wait for the update to arrive over here. So here we can provide the SKUs for each individual resource that is deployed within the account, and we would have to change basically the app service plan tier. The end device, after a while, the end device has been created because it took a bit for the function to execute, because we are trying to keep the costs. So since this is an operation that you don't do that often, the end device has been created. We should now be able to see it here. It hasn't joined yet because we've just deleted the old session. I'm going to reset it. And unless we are receiving surprises, we should also see the join accept over here, and then we can look at the device twin as well. So now we're waiting for the end device to join. This is the wrong end device. I'm interested in the things node. Yeah, the things node. I go to device twin. As part of the tags, the app key has been deleted. We don't store it after we use it, we delete it. And now we already have our first reported state. So the device has just joined 15 minutes into the into the webinar, and we have the first payload that we received. So battery, light, temperature, and so forth. And we are good to go. We didn't have to do anything in the thing stack. We just created the device in Azure IoT Hub, and that was it. Another functionality that you can use with Azure IoT Hub is the querying functionality. Azure IoT Hub has this beautiful property where you can actually use a SQL-like language in order to query and obtain information about your end devices. So you can access this just above IoT devices in Query Explorer. Let me just refresh so we start with a clean slate and I walk through with you through this. Yeah, by default, the query is quite simple. It selects everything, every field for all of the device twins which are available. We will run this, and what we will receive is a JSON array of device twins. So the first device is our actuator, the thing Zuno, which has a LED on it, and the second one is the things node, which actually acts as our sensor. Now, this is nice, but it's quite a bit of information. So let's try to refine it a bit. Let's say we're interested only in the device ID, in the LoRaWAN tags, and finally in the reported properties. So properties, reported, and then decoded payload. We will run this, and unless I did any spelling mistake, we should be getting two devices, and we do. We get first just the device that is the actuator, so the UNO, and below it we have the sensor. You can also do filtering on this. So for example, we can actually just select all of the devices which, let's say, have the LED turned on. So we do exactly how you would do in any SQL language. You use properties, reported, decode the payload, and then LED state. This is the variable that holds whether or not the LED is on. And let's say we are looking for things which have the LED turned on. And we have the actuator over here. We can also, let's say, modify the end device that we're using. So go back to the actuator and let's turn the light off. So we ask for, we desire that the LED turns off. We see the downlink already being scheduled over here. I guess we're in RX1 and did it reach the end device, waiting until the next uplink. Yeah, and we were not in time for RX1, but we are going to be in time on the next uplink, which should arrive in about 5 seconds. This is how it usually happens. And the LED state is going to be turned off or not. See, this is interesting. This is what happens when you use boot devices. When this happens, it means that maybe the downlink didn't reach the end device. So what we can do is that we schedule the same patch again. We turn off the LED. As you can see here down the desired properties, you have this metadata. Metadata represents basically information about when the field has been changed. So for example, when we update the desired properties of an end device, the metadata is automatically updated by IoT Hub, and we can check, okay, when was this last updated, what was the last version, and when was updated, when each field was updated, sorry. We do this again, so we submit the patch again. We again have a new downlink, which we try to reach, send to the device, and now the LED has finally been turned off. We also should be seeing this in the device reported properties. LED is now off. We run the query again, and we shouldn't be finding anything. And we're not. We can also do the same for temperatures. So let's say we want to check if we have any sensors which detect the temperature over 20 degrees, and we find our temperature sensor. This should be it regarding most of the getting started part of this integration. I've shown how you can use device twin, how you can actually see the integration communicating with the thing stack, and how to use the querying capabilities. Now, how this one can be used, let's say, in order to integrate it with other Azure facilities, you will have to look into stream analytics. Stream analytics will allow you to connect basically an IoT hub to, let's say, a Power BI data set and to plot this data. This is a bit outside of the scope of this tutorial, but we will provide some tutorial links on how to actually achieve this. Now, most of the things which I've shown here are from, let's say, a static device twin perspective, but let's say you want to actually deal with live data. How you do this in IoT Hub is via message routing. One of the ways, because there are many ways in which you can receive data from IoT Hub. Message routing basically allows you to create endpoints to which data should be sent. So by default, we create an event hub, which we use in order to receive events such as device created, twin desired state updated, and so forth. And this is what you're going to see here under event hub. But let's say you are interested in just receiving telemetry, you would create an Azure event hub, add it over here, and then you would have to create a route. What we are going to use here, however, is the default fallback route. Basically, when what happens is that you can allow a default endpoint in which all of the messages are going. Unfortunately, we cannot see it via the Azure portal. They don't give a subscription capability over here, but instead we're going to switch to my IDE, VS Code, and I'm going to do that now. So allow me to switch the screen for a moment. Yeah, so hopefully now you're seeing my VS Code screen. VS Code, a very good IDE from Microsoft. It has extensions, built-in extensions for Azure IoT, especially. So you go over here, over extensions, Azure IoT tools, and you install it. It's a pack of a couple of Azure IoT related extensions that you can use. The one which we are interested in right now is, since we would like to see live traffic coming from the end devices, you will have to connect to your IoT Hub. I already have it here pre-selected not to go through a login round, and you will start monitoring the built-in event endpoint. And what we can do now is that we start sending telemetry. So I'm going to force my my things now to send data. Just a moment. Sometimes it gets stuck, but this is a hardware failure, unfortunately. But we can always reset the battery. Wait for a bit until it joins the network. Yeah, we have a join request and a join accept, and we actually can see it here live. So this is the telemetry that we push. So this was the join. Here you can see when it was received and was the session key, and then we start receiving metadata. The JSON format that is being used for the telemetry is the same JSON format that we use everywhere. So if you've ever interacted with the Think Stack and have used the MQTT, webhooks, even I believe the AWS IoT Core integration, we use the same standard JSON format everywhere, which contains identifiers for the end device and the message itself. So decoded payload, which gateways have received it. In this case, this message, for example, also was received via packet broker, what spreading factor, bandwidth, all of the telemetry that you need to know when you are trying to receive data. Now, why I'm showing this, why I want you to know about this particular extension is that because it helps you really a lot while debugging and while building your actual, let's say, pipeline, because you can actually see live what messages do you arrive, what kind of fields they contain, and then you can adapt your pipeline based on this. You can also stop monitoring, and that's it. I believe this was everything that I wanted to show specifically regarding the capabilities of our integration, and I'm going to switch back to my normal screen and look for questions. Takes me a bit of a minute until I switch to the right one, but So hello, Sander. I believe so. And if not, this is something that we should be fixing. So the question from Sander is, are messages sent to IoT Hub instrumented with content encoding UTF-8 and content type application JSON? This way, the IoT Hub routing has access to the body. I believe they should be. And otherwise, if you see any other problem with that, please let me know and we can fix it as soon as possible. I don't think this should be a problem. By default, we do send them as JSON, so this should be the case. A bit of basically the timeline for this integration. So we've had it available both on the Things Network and the Things Tech Cloud for about a month now, since the release 3.14.0. And right now we are looking as much as possible for feedback on what type of features people would like to see. A very requested one, which is within our pipeline, is basically selecting what type of telemetry you want to send. So for example, if you're not interested in updating the reported properties of the end device, we're going to add a checkbox that say, hey, please don't update that. Or a capability such as selecting what type of telemetry we send. So if you just want to see just top links, you would filter to receive only those and so forth. Yeah, so application properties would help for routing. Right now, how I would recommend that goes is via tags. So right now, let's go a bit and show this for everyone. So one moment. Yeah. So message routing, indeed, you can actually add filters. So message routing allows you to actually select which type of messages you would be interested in. This routing areas is presented over here. I believe what I am pretty sure is that you can access the device tags. So you can, for example, you can listen for device pin changes, and then in that one you should be having tags as well. Otherwise, the other solution is to actually um, make some kind of protocol within your payload formatters, let's say. That's another solution that can be done. Indeed, the downlink messages rely on the downlink payload formatter. So in this case, I'm lucky enough that it's symmetric in a sense. The payload formatter used for uplink has the same format as the one for downlink, the lead state one. How it works? Oh, I do not see the screen. One moment. Thank you. Okay, so I'm going to come back to your question, Jack, in just a moment. Sorry, I didn't realize that the screen was not visible immediately. So going back to message routing, to give a bit of more details here. So let's say you would be interested in adding a route to an event hub. I'm just going to use the stack events one, for example, and you provide here a query. So things like properties dot reported decoded payload, and let's say let state equals on. This is the type of query that you would provide in order to force messages that only fit this query, so that only trigger when the let state is on to a particular endpoint. Yeah, and this is, for example, how the thing stack actually achieved this. So while we receive all of the lifecycle events, a lifecycle event is, for example, device created, device deleted. We receive all of them. We are interested, for example, only when we have desired property changes. So we achieve this via routing query, and this routing query says that we actually have a desired property in the body, or we actually the tags of the end device have been changed. This is how you can use a routing query. The first one is obviously for downlink. The second one is for device creation, because only when we have the tags we actually have the information that's required for LoRaWAN. Now, going back a bit to the question that Jack had about how downlink works, downlink is indeed dependent on the downlink payload formatter. So how it works, and we can actually show this, is that when you update a desired property, you're generating a patch. So let's call, and the patch is actually partial, is that it does not contain the whole desired state. So if I use here prop1, I'm just showing you that it's not going to include everything, and prop2, 2. So now it's a valid JSON object. And what is going to happen once the downlink comes is that you will see that we have everything that was included in the decoded payload. And if I remove them, again, I'm going to generate a downlink, which has only the fields which I've added. This requires support from the payload formatter. Most of the how I use this in general is that I just include the fields which I know that are supported by the payload formatter. This is why, for example, when you add an end device, we recommend that you provide those end device version identifiers that I've had, for example, for my node for the telemetry device, because then when we create the end device, we know, okay, those I can use the payload formatter in the device repository. I also know that some people don't actually have a bit of a problem finding out how to find those. This is actually present in the console. So after you have created an end device that respects that is actually part of the device repository, all of this information is available here under hardware. So the brand is the Things products, the model is the Things node, and hardware and firmware version are 1.0. And then those are the values that you need to provide when you enroll other devices. The band ID follows the frequency plan. So since I'm right now streaming from EU, I'm using UE 863.870. Any other questions? Any activity or any recommendation that you're looking for in the audience? This sometimes happens when you resize the Azure portal screen. Say gets fixed with a reload. Good. I'm going to be taking questions for a couple more minutes. Okay, looking at a question from Alset. What color shall Alset? So there are two questions right now. Creation of devices can be done by another application on top of the IoT Hub, indeed. So how it works is that if you just have your own already existing application that you control directly via the APIs that are provided by the Things stack, That's perfectly fine. On the first uplink, we are going to check if the device exists in IoT Hub, and if it doesn't, we create it there, and we start sending telemetry. So if you already, let's say you are using the mass import capabilities of the Think stack, you have those JSON files that contain the device definitions, you create all of them in one application, and as soon as they start sending messages, we're going to create them in your IoT Hub. So definitely you don't have to, if you have already another flow that you use to enroll your devices, that's perfectly fine. You can use device claiming as well and so forth. Going back to the next comment from Utkarsh, I don't see the question there. If you could clarify that, please. We are waiting for a follow-up from Utkarsh. Are there other questions which I can answer? If you're looking for tips and tricks or architectural decisions, I can probably help you with that. I'm the main developer of the integration side of the things stack. Glad to hear that. Yeah, I guess that since we're no longer having any questions left or anyone looking for advice, we will wrap it up here. Thank you for participating into this webinar about Azure IoT Hub, and I'm very glad to hear any future feedback that you have regarding our stack. Have a nice day.